IP address or Internet Protocol address. So we are taking the multiple choice questions on it. How many versions of IPs are there? See, IP addressing scheme is to implement the Internet Protocol basically. So there are two versions. One is IPv4. The other one is IPv6. Internet Protocol version 4 or Internet Protocol version 6. So this is how we write it. So the format has come from a lot of experimentation and different kind of technologies. Finally, we settled down to the dotted decimal form. So this is a decimal number 192 which you see here, and all these numbers are in decimal and they are separated by dot. All these numbers are 8-bit. So 8 4s are 32. So the total addressing space or number of addresses which can be generated is 2 to the power 32. And IP is of course Internet Protocol. And if you want some communication or networking, you have to first locate your destination, and then you have to find out the actual host. So this IP is basically to find out or to locate a system or a host in a network. So you can call it as a unique number, but this is unique only when it is combined with MAC address. MAC is actually the unique number, and all these IP and MAC combined will start the communication. So this IPv4, as I said, 2 to the power 32, that is around 4 billion addresses can be generated. But the problem here is that we are 8 billion. There are only 4 billion possible. Assume that we are 8 billion and assume that one person is having a laptop, a tablet, or other device, you can name it. So this laptop, computer, tablet, all these a person can have. So 4 billion is very less. For that we wanted IPv6 or some version so that it can actually accumulate or absorb all kind of experiencing and advancing numbers of hosts. For that IPv6 has come. 128-bit it is, 2 to the power 128 is the addressing possible. So all these 16, one is 16, not 8. Okay, please remember this IPv4 8-bit and this is 16-bit dotted decimal. But here it is not decimal, it is hexadecimal. Difference you understood? This is decimal, this is hexadecimal. Dotted form 128-bit. So these are two versions. They are only for addressing and knowing the location or identifying a system on a complete network. So two versions of Internet Protocol. What is the format of IP address? See, IP address, the format, because there are two versions actually. So what is the question? The options are, the answer will be 32 because there is no option of 128. So you can only go with 32-bit. But if this question has come for IPv4, this question can be what is the format of IPv4 address, or the question can be what is the format of IPv6 address. So the IPv4 is a 32-bit address, 8888, all these decimal dotted, and IPv6 is 128-bit, 1616, around 8 times. So 16 into 8 is 128. So IP, we generally talk about IPv4 by default, but since the computer and the systems IPv6 have advanced, now people have started using IPv6. So the format of IP address is a 32-bit numeric address written as 4 numbers separated by periods. So this is the first octet I am showing you, 192, and each number can be 0 or 255, right? For example, we have this binary 192. If you convert it into binary, 192 is decimal. You can convert it into binary, and that is how the binary form 1 bit. If you consider or you compute the numbers, it will be 32-bit. For this IPv4, and similarly you have to do it for IPv6. So they are 16 16 16 separated by dot, and there are around 128 of them. So if I just write this 10.20.16.19 in IPv4, we know that it is class full. IPv6 has no class. So IPv4, this particular address which I wrote is actually a class A address. because the minimum possible IPv4 is 0.0.0.0, the maximum is 255.255.255.255. This is the IP address, and you know these two addresses cannot be used. They are reserved for something. Now I would like you to tell me why these are reserved. Why we can not use this as a host address or a network address? Version 6 of IP address has how many bits? So we have just seen version 6. How many bits? 128 bits. This is hexadecimal. And why it has come? Because the IPv4 was a 32-bit addressing scheme. 2 to the power 32 is 4 billion, and there are 8 billion of us in whole world. So we need, and every person has 2 or 3 gadgets. So in order to get IP address for all of them, we need a high numbered addressing scheme. Okay. So this is how the growth of internet and depletion of IPv4 address. New version has come using 128 bits of IP address, developed in 1995, standardized in the RFC 2460 in 1998, and since then it is just going on, and maybe in few coming years we will be actually jumping to IPv6 and IPv4 will be depleted, but there are ways of tunneling, etc. Both can go simultaneously, but still 128 bit, since it is for beginners it is complicated, that's why still IPv4 is being used. So the final answer is 128 bit. Version 6 of IP address has how many bits? 128 bits. Version 4 has 32 bits. IANA. So in IP addressing scheme or IP address, why we have IANA? Okay. Now if you have a road and there is a traffic police, especially in India, the people will stop. People are going to stop. Or signals are there, people will stop. So there has to be some governing authority or a person or a community which guides, which make rules. So IANA, if you talk about IP address or MAC address, media access control. See, IP and MAC address governed by IEEE. So what about IP address? Who is going to govern that? So it is IANA. Now this IANA stands for what? I'll show you the logo and you will answer by yourself. This IANA is Internet Assigned Numbers Authority. Internet Assigned Numbers Authority. IANA. Alright. So all these are similar, but the answer will be Internet Assigned Numbers Authority. So what it does? See, there are IP addresses. Now there is a scheme, proper scheme. So IPv4 we have a scheme 0.0.0 and then 255, highest can be 255, 255, 255, 255. 2 to the power 32 addresses are possible. Now there is broadcast address, there is private address, there is a loopback address, there are so many addresses. Who is going to govern that? Along with this, the CIDR. When a company asks for a certain block of IP address, the CIDR, the authority IANA will give it to the RIR. RIR will give it to the other ISPs basically. It will go to ISPs, and those small blocks will be allotted only by the final ISPs. But it all will start with IANA. So the IP address is managed globally by the IANA and by 5 regional internet registries responsible for their designated territories for assignment to end users, and local internet registries like the ISPs. So I hope you have now a fair idea of RIR now. So RIR stands for what? The answer, can you answer this? You have just seen it. Okay. So this is all regional. So Internet Assigned Number Authority IANA assigns larger blocks to RIR. What do they do? Now if somebody in CIDR format, especially CIDR, okay, you have to tell me this CIDR. I have already talked about that. So this is Classful or classless? What is D? Domain, routing. Okay. So classful, we have private addresses. You know, there are private addresses, public addresses. But in classful, we have A, B, C, D, E. For example, 127.0.0.0 or everything with 127 starting will always be taken as a loopback address. This is classful. But when we come to CIDR, there is no class. In CIDR, we don't have any class. So CIDR is simply IP address followed by a slash followed by a number. And that number will give you how many network bits are there, how many number of ones are there. So when a company comes and asks for a large block of IP address using CIDR, then who is going to give it to them? If I write an address 142.2.1.6 and /5, that is the first 5 bits are reserved for the network address. Others are for the host. So I'm just giving an example that these kind of numbers or these kind of addresses need to be given to some people or some organization or company who wants them. So who is going to give them? The main authority is IANA. Now this Internet Assigned Number Authority, as I just said, they assign the larger block to RIRs. What are RIRs? Regional Internet Registries. This is regional internet registries, and in turn this RIR, they create smaller block and assign them to LIRs. What are LIRs? Local internet registries. You can also get the question like what is LIR stands for. For that you have to give the answer as local internet registries. So INA, then RIR, then LIR, and finally the ISP. The Internet Service Provider or ISP is actually final in charge of assigning blocks to an end user for their private network. So this RIR is, you can call it as an organization that manages the allocation registration of internet number resources within a region of the world. And this internet number resources include IP addresses and the AS numbers, autonomous system numbers. VLSM. So we just talked about CIDR. This concept is CIDR. Or to be very precise, this CIDR is based on this VLCM only. So we are talking about CIDR. I hope you might have got what is CIDR acronym up till now, and you might have commented it also. So A, B, C, D, E. These are the different classes for classful addressing IPv4. But how about classless? Okay. See, for example, let us see about the loopback address in the class full addressing. So 1 to 127 is class A, 127.0.0.0 and till 255. We cannot use it. It is only 127.0.0.1 which is used as the loopback addressing. So 2 to the power 28, because 4 are fixed in this class. So this kind of wastages will take place. Alright. So this kind of wastages is not acceptable. That is how this CIDR has come. I'll give you one more example. In class C, only the hosts possible are 254. But if you want more of them, like 255, you just have to jump to class B, and that will be a huge number. And A is more huge and gigantic addressing scheme or addressing block. So this VLCM especially has come up because of CIDR. This /12 means there are number of ones in the and governing the network address. Other will be host address. So the basis of CIDR is VLSM, variable length subnet masking. VLSM full form, variable length subnet masking. So in class C, for example, we have this subnet mask. But in CIDR, we don't need any subnet masking. Okay, this is a variable length subnet masking, VLSM. So I hope you got the idea. VLSM is the basis of CIDR because the subnet mask, which is fixed for class A, B, C, is not fixed here. It is variable length. Variable. And please remember, class D and class E, they don't have any subnet mask. So we will not talk about that. The design of the Internet protocol suites adhere to the principle. Now the whole idea is that if I give you a packet to deliver it to somebody, until he receives it, the communication is not done, not possible, or not successful. So we have the ISO OSI layer stack from application to physical layer. So just say one is device 1, one is device 2. So the packet starting from application layer of one device, it has to reach after going through all the different layers from application, presentation, session, transport, network, and then this DLL, and then physical. So it has to go from top to bottom and then again back from bottom to top to the other device. So the application layer, until they both get send and receive the packet, the things are not done. That is why we call it as end-to-end principle. I hope you got the idea. So in a network design according to this end-to-end principle, guaranteeing certain application specific features like the reliability and the security, it requires that they reside in the communication or communicating end nodes of the network, which I just told you as the application layer, that is the starting layer. In between, we may have any problem in network layer, not our concern. Physical layer we'll see. But our idea of designing the internet protocol suites was only that it has to be end-to-end. So this end-to-end principle is a network design method in which application specific features are kept at communication endpoints. Again, same thing. If I say I'm sending 128, you should get 128. So this design of the internet protocol suite adheres to end-to-end principle. This concept has come from where? It has come from Cyclade's project. So under this end-to-end principle, the network infrastructure is considered inherently unreliable at any signal network element or transmission medium and is dynamic in terms of availability of links and nodes. We don't worry about, because everything is changing. Everything, for example, the packets are going through different routes. So this is end-to-end, has to be end-to-end. Next is geolocation software is used by host. Now this is, you'll ask why you are asking this question. This will never be asked, but it is very important. It is true. Why? All the Swiggies, all the Zomatos, all the Olas and Ubers. What happens here? What happens? A header, IP packet header, will have the IP address of the host of the destination. So when we have the destination IP, can you locate that IP? So if you have any geolocation software, you can find out the geolocation of its communication peer. So this is IP-A, IP-S, let us do IP of source, and IP-D is IP of destination. Geolocation is what? Finding out your location using the latitude and longitude. So lat long will give your precise location on this globe. So when you are aware of the IP address of that particular host which you want to send, or that is called destination, and that destination, when you know that this lat long is there, if you are able to find out, you can locate it also. So geolocation software is used by host. That is absolutely true, because geolocation and IP are related like that. IP will show you the location. So I hope you have a better idea of IPs now. Thank you so much.